0, June 10th, 2026. Right now marks 2,591 hours of progress on the global heart simulation. Currently, the voxel-based fog of war has been made to be crash-proof. In a recent test, the program ran for 2 hours straight without a crash at any point, and so previously the program could not run for more than about 10 minutes without crashing, and what would occur is the program would freeze up, the editor, and then also other programs on the same machine would start to freeze up and report different Win32 error messages, such as stack overflows and other programs reliant on the GPU crashing. And so after some testing, what was found to be the cause of that was a mismanagement in the usage of a compute buffer. And so the intention was to take a compute buffer and update it every single frame, but what was actually done mistakenly was allocating a new compute buffer, which was creating a new GPU object every single frame, and eventually that would basically use up the GPU resources and cause the entire machine to freeze up and all programs to crash. And so now that that has been corrected, the program no longer crashes after 10 minutes and has been able to run for 2 hours without any crash within that time frame. And after the 2 hours, it was decided to stop testing it and then do a different stress test, which is the amount of objects in the scene. And currently there are 2,000 objects in the scene. And how this is working, we got the level itself is divided into its own voxels, which are used for the 3D visibility masking effect, as seen here. And there are currently 125,000 voxels, but in order to know which parts of the scene have actual 3D geometry within them already, every single object is divided into its own bounding box. And then those bounding boxes are subdivided into their own voxels. And in those voxels, what it's done is to see the corners that are shared between those voxels and then store the corners, although these information doesn't really need to be stored since every object here is static and non-moving. It was just thought to be done as a stress test. So there's 4 million total local voxels to objects in the scene, including the border walls, and of those there are around 9 million corners. And the reachable voxels, which it says are 2.3 million, are the actual voxels that are within range of the entire grid being used for the level. So some corners would be outside of the grid if they are along the very edge, but the grid does stop at a certain point. But the actual wall objects, the border walls, are actually taller than the grid, or at least their bounding box is, although that doesn't seem to be able to be shown here since the actual editor is freezing up since it's slower than the actual program, since the editor is drawing voxels using CPU code, but the actual voxels themselves are processed on the GPU. And so the intention going forward, now that this is able to run without crashing, is to implement line of sight logic into it and test that with thousands of objects in the scene. And so an algorithm has already been created previously for a line of sight that was able to run seemingly on 1 million voxels per millisecond with good performance and calculate line of sight for every single voxel simultaneously within that grid. And so the intention is to integrate that into this system in order to have fully 3D fog of war with line of sight, and then test it with the thousands of objects simultaneously.